This is Unit 9, Lesson 3, the law of cosines. So in Lessons 1 and 2, we did trigonometric ratios that dealt just with right triangles. What we're going to look at now in Lesson 3 and Lesson 4 are two rules that let us use a version of cosines and a version of sines on triangles that are not right triangles. So the trigonometric ratios in the previous lessons could only be applied to right triangles. However, there are two laws, and the first of them that we're going to do is the law of cosines. The law of cosines is fairly simple to use. It just looks really long and complicated. And the most complicated part of the law of cosines is identifying the parts. So the law of cosines is just c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. It's a lot of stuff. So we want to take the time to make sure we identify all of the parts, we identify them correctly, and we know exactly where they go in the formula. So when we calculate this, C is going to be a side of the triangle. It's going to be either opposite a known angle or a missing angle. And it stands by itself because it is on the right or the left side of the equal sign. A and B are the measures of the other two sides of the triangle, and they're on either side of that known or missing angle. And that will make a whole lot more sense, I hope, here in a second when we fill in some examples of just filling in all the parts and identifying the parts. The cosine of C is the angle that is in between A and B. So this angle, whatever it is, whether it's angle C or it's got a number to it, it's got to be in between those two sides that we labeled A and B. So the first couple of examples are just filling in a law of cosines formula. So let's write down the law of cosines. C squared equals a squared plus b squared minus 2ab times the cosine of C. All right, so let's identify the things that we know. We know that angle E is 12 degrees and it's opposite FD. We don't know the measure of angle F, but we know that it's opposite side ED, that's 16.8. And we don't know the measure of angle D, but we know that it is opposite side EF that measures, actually that's an 18, measures 18. And what we want to do in this particular problem is right now we just want to find the length of FD. So we're going to set this up as if we're trying to find the length of FD. So the first thing you need to do is you need to identify what is your A, your B, and your C. So your C is generally the thing that you don't know. We start out by saying that our C is the thing that we're looking for. So we don't know X. We don't know the value of X. Our A and our B are going to be on the other two sides. It doesn't matter which one you call A and which one you call B. I'm going to call 16.8 A and I'm going to call B 18. What's important is that they're on either side of this angle that we know. We know that the measure of angle E is 12, and this is on either side of that. So in this problem, our cosine of C will be the cosine of 16. So when we set this problem up, we'll say C squared equals 16.8 squared plus 18 squared minus 2 times 16.8 times 18 times the cosine of 16 or 12 degrees. Now, when we're looking for different things, our A, our B, and our C are going to change because they're going to change in relationship to either the side that we're looking for using the angle that is opposite it, or they're going to change because of their relationship to the angle that we're looking for. And you're going to see that a lot in the last two examples. So in example 2 here, we have a different triangle, and we know that angle L is opposite NM, and it measures 10 feet. We know that angle N is opposite LM, that measures 12 feet, and we know that angle M is opposite LN, that measures 8 feet. And our instructions were to identify the parts, construct a law of cosines equation to find the measure of angle L. So we need to identify our A, our B, and our C. I like to start with my C, actually, instead of my A, because my C is going to be opposite either the angle that I know or the angle that I'm looking for. So in example 1, my C was opposite the 12 degree angle that I knew. I knew that this angle was 12. this was opposite that, so that's my C. So in this example down here, I am looking for angle L, which is right here, and opposite angle L, go to the other side of the triangle, is that 10-foot side, so that's 10. And then I know my A and my B are just the other two numbers, so they're 8 and 12, 12 and 8, the order is not important. And then the cosine of C is just going to be, you can leave it as the cosine of C. Because I'm looking for angle L, I'm going to call it the cosine of L. And then we're going to plug it in. Remember, our formula is C squared equals A squared plus B squared minus 2AB and the cosine of C. So C squared is 10, A squared is 8, and B squared is 12. Notice this squared is part of the original formula, just like the Pythagorean theorem. So when I put the numbers in, I put the squared with those numbers. And then 2 times 8 times 12 times the cosine of L, because this is what I'm looking for. So make sure that you are identifying the parts correctly. Once you identify the parts, the rest of the problem is actually very easy to solve because you can just type it in a calculator. But until you've got the parts identified correctly, it's not going to come out right. So in example 3, we want to find all of the missing side lengths and all of the angle measures. So this is going to take what looks like a lot of work, but most of the work is in identifying the parts. We know that angle A is opposite side BC, that's 7. Angle B is 100 and it's opposite AC. C is opposite side AB that measures 5. So the things that we need to know. Well, from here, we need to find the measure of angle A because that's missing. Here, we need to find the measure of AC because nothing told us what the length of AC was. And in this line, we need to find the measure of angle C because all we know is the length of the side opposite it. So we're going to start by finding the side length because that's the easier of the three, actually. So we need to identify. So to find AC, I'm going to label this and hopefully keep it all straight. To find that missing side length, we need to identify our parts. C is the thing we don't know. It's what we're looking for. A and B are the other two sides, so they're 5 and 7. And the cosine of C is the angle that's in between those two sides. And that angle that's in between there is 100 degrees. So it's the cosine of 100 degrees. So we start plugging things in. C squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 100. You're going to just type all of that in your calculator exactly like you see it. Pay attention to parentheses. Make sure you close all parentheses that you open. But I would type every bit of that in my calculator because if you type it all into your calculator, just as this right here, 85.2. Now, this is C squared. I don't want to know the value of C squared. I want to know the value of C. So I do the square root of both of those things. And I'm going to round to the nearest tenth. So 9.2 is the length of AC. So now let's start looking for missing angle measures. Let's find the length. Let's find the measure of angle C first. At this point, because you know all three sides, what you need to look at is what angles you do know and what side you know. We know all three sides, so we're going to find the measure of angle C. So to do that, we need to identify our A, our B, and our C again. So C, this is what I'm looking for. This is the side, the corner that I'm looking for. So C needs to be opposite that. So I'm going to go over here. Opposite C is 5. So C is 5. And then my other two sides that are on either side of my angle are my A and my B. And I just calculated that this side right here was 9.2. So 9.2 and 7. And the cosine of C is actually the cosine of C because that's the side, that's the angle, the name of the angle I'm looking for. So I'm going to plug all of this into the formula again. But now I know that C squared is 5, and that equals 9.2 squared plus 7 squared minus 2 times 9.2 times 7 times the cosine of C. Oh, that's a lot of work. I understand. So let's simplify. 5 squared is 25. 9.2 squared plus 7 squared. I just type this into my calculator and I get that together those are 133.64. And then I'm going to multiply 2 times 9.2 times 7 and I get that that is minus 128.8, and I'll still have the cosine of C out here. Now I just need to solve for the cosine of C. I need to get it by itself. So this is all stuck together. So I'm going to subtract 133.64. And that's going to give me negative 108.64 equals negative 128.8 cosine of C. This says negative 128.8 times the cosine of C, so I'm going to divide by that. Now, here's where you got to stop. And you got to remember, when you're looking for a missing angle measure, you use the inverse. So I don't want to do cosine of C and just divide these two numbers. It's going to give me something crazy. I want to do these two numbers as the inverse of cosine. And I know you're looking at it going, there's negative numbers there and they're crazy numbers. I understand that. They're still going to work out because a negative divided by a negative is a positive. So when you change this, because we're looking for an angle measure, we change this to the inverse and we type it all into our calculator, you're going to find that angle C equals 32.49, and we like to round things, we like to round degree measures to the nearest whole number, so that's 32 degrees. So angle C is 32 degrees. Now, we could do all of this same work, or similar work, to find the measure of angle A, but that's a lot of work to do, when if I know that angle B is 100 degrees, and I know that angle C is 32 degrees, to find angle A, I can say 180 minus 100 minus 32. I completely and totally expect you to use this shortcut. This is called the triangle sum theorem. It's not like I'm asking you to do something crazy. It's something you've done before. Use what you know. At this point, we're going to start using what we know. We're going to pull in things like the Pythagorean theorem. We're going to pull in all of our rules all together. And in the last lesson, we're going to do everything using all of the rules that we know. So the measure of angle A is 48, because all of that subtracted is 48. The measure of angle C is 32, and the length of AC is, what did we say, 9.2.